Hello everyone, welcome back to chemistry. Today we're going to be talking about making measurements and a little bit about accuracy, precision, and some significant figures. So whenever we're in a lab, well, you know, if you're ever in a lab at some point, this is just important to know when making measurements. Even when you're in the kitchen and you're making liquid measurements, this is important to know, like if you have to be super exact. When you're making a measurement that's a liquid measurement, you want to put your eye level with whatever you're measuring, so the surface of where it is, and the meniscus is this bottom part here. And that's where you want to measure. You don't want to measure where it is on the top. You want to measure where it is on the bottom here. Okay, so for instance, this measurement here would be, oops, we'll go back, would be 10, 11, 12, 13, 14. This is in milliliters, so it would be 14 milliliters, right? If I measured it from here, it'd be 15, but that's not correct. Why does it keep doing that? So practice with these two. Try to figure out what these are both in milliliters. So try to figure out what this measurement is and what this measurement is. I'll give you a couple seconds. You can pause the video or whatever. Okay, so this left one, the meniscus is right here on this line. Okay, and that's right above the 6.5. 6.5 is right here. So this here would be 6.6 milliliters because it's in between the 6 and the 7. For this one, we're right below the middle point between 20 and 30, which is 25. So that means this line here is 25, and it's the one below it, so that means it's 24 milliliters. All right, so in chemistry, we can describe a measurement in two different ways. We can use accuracy. So that's an indication of how close a measurement is to the true value. For instance, they really like to use like dartboard examples. If your measurement is accurate, that's kind of equivalent to hitting the bullseye. Okay. So, and then precision is an indication of the scale on the measuring device that was used. So precision would be if you threw a bunch of darts on a dartboard and all of them hit around the same area, like this first example, these would all be precise, right? Because they all are about the same, but they're definitely not accurate because they're not hitting the bullseye. Okay, for this one, we have a dart here, a dart there, dart there, dart there, dart there, dart there. It's pretty close to being accurate, right? But it's not precise because these measurements are all over the place, but we're getting close to accurate. The darts are all over the place, not anywhere close to the bullseye and not anywhere close to each other, so they're neither precise nor accurate. And then for the last example, they're all clumped together around the bullseye, so they're both precise and accurate. So the more correct a measurement is, the more accurate it is. And actually, the smaller the scale of the measuring instrument, the more precise the measurement. For instance, if you're in the kitchen and you're using a liquid measurement, like one of those Pyrex liquid measures, and let's say you have a really big one, so you have a 4-cup measure, but you're trying to measure like half a cup or maybe even a 1/4 cup. Well, that's really hard to do with a 4-cup measure because it maybe is not as precise as, let's say, a 1-cup measure where you can pretty easily get a 1/4 cup from that. So the smaller the scale of the measuring instrument, the more precise it is. And a measurement precision depends upon the instrument, whereas measurement accuracy depends upon the person doing the measurement. So precision depends on the instrument, accuracy depends on the person doing that measurement. Okay, and to determine the precision of a measurement, we need to look at its significant figures. So if two instruments measure the same thing, the one which gives you a significant figure in the smallest decimal place is the more precise instrument. So the one that gives you a significant figure in the smallest decimal place. So for instance, 1.001 is more precise than 1.01, if that makes more sense. But what is a significant figure? So a significant figure is a digit within a number. Okay, so a digit within a number is considered to be a significant figure if, one, it is a non-zero. So any digit that's a 1, 2, 3, 4, 5, 6, 7, 8, 9, those are all significant. Or if it's a 0, then it has to be between two significant figures. So maybe like 109, so 109, so the 0 is in between the 1 and the 9. Or if it's a 0 at the end of a number and to the right of the decimal point. So we have a non-zero, or if it's a 0, it's between two significant figures, or it's a 0 at the end of a number and to the right of the decimal point. So that an example like that would be like point or decimal point. So 0.190. That 0 on the end, even though it doesn't really mean anything, like, for instance, in math, it actually means a lot in chemistry. It means that that measurement was made to the thousandth place, so it's more precise. So that 0 on the very end is significant. And the 0 on the end of a number is significant only if it's to the right of a decimal point. All right, so let's do these examples. So count the significant figures in each of the following numbers. So let's start with A, 3.234. Okay, well, looking at our rules, I don't see any zeros in this number. And our first rule says that it's significant if it's a non-zero. So that means all of these digits are significant. So there are exactly 4 significant figures in this numbers. 1, 2, 3, 4. Okay, what about B? 6.016. Looking at our rules, we do have a 0 in this number, but it's wedged in between two digits that are significant or are non-zeros. So that 0 is also significant. So that means there are 1, 2, 3, 4 significant figures in this number. All right, C, 105.340. Okay, we have 2 different zeros in this. Let's look at the first 0. So the first 0 is in between 2 non-zeros, so that means it is significant. And the 0 on the end. If we look at our rule number 3, it's significant if it is a 0 at the end of the number and to the right of the decimal point. Is this to the right of the decimal point? Yes, it is. Is it at the end of a number? Yes, it is. So it is significant. So we have 1, 2, 3, 4, 5, 6 significant figures in this one. All right, and lastly, D. We have quite a lot of zeros in this one. Let's look at the first one. Okay, the first one is not significant because that's just a placeholder. What about this one? Is that one significant? Well, it's not in between two significant figures, and it's not a 0 at the end of a number, but it is to the right of a decimal point, but it's not at the end of a number, so this one's not significant. Well, if this one's not significant, then neither is this one. Okay, so these 3 zeros are not significant. All right, now we have a 4 and a 5. Well, those are automatically significant because they're not 0. 0, 0. So these two zeros are wedged in between a 5 and a 1. Now, some of you might be wondering, well, what about this 0? It's wedged in between a 5 and a 0. That's okay. That is still significant. And that's the same with this one. 0 is wedged in between a 0 and a 1. Because the two zeros are wedged in between the 5 and the 1 here, you know, you wouldn't cut off the number at like one of these zeros, for instance, because there's a 1 here, but these are significant. All right, that 1 is significant. What about the 0 on the end? According to rule number 3, it is a 0 at the end of the number and to the right of the decimal point. So that is significant. So we have 1, 2, 3, 4, 5, 6 significant figures. Okay, and those are just the answers there. All right, so I want you to practice with this. Do 1.0 or 1.10 on your own. And we'll see you later.